Hello everyone, this is Dr. Rajesh and today I am again with you with my new video lecture, and this video lecture is on the topic subgroups, and in this video lecture we will study an important result concerning the subgroups. So this result will prove an important tool to prove any subset H of a group G to its subgroup. So the result is given by a necessary and sufficient condition for a non-empty subset H of a group G to be subgroup is that for any A belonging to H, B belonging to H implies that AB inverse belonging to H, where B inverse is the inverse of B in G. Firstly, let us suppose that H be a non-empty subset of group G. Now we have to prove condition is necessary. For that, let us suppose this condition that H is subgroup of G. Then we have to prove this condition. Okay, condition is necessary. Let us suppose that H is subgroup of G. So required to prove for AB belonging to H, we have AB inverse belonging to H. For the same purpose, let AB be two elements of H, any elements. And since H is subgroup, implies H is subgroup, then it means it is itself a group with respect to the same binary operation. And the properties of group are that inverse of every element will exist, implies that B inverse exists and B inverse belonging to H, because if H is subgroup implies inverse of every element will exist will exist. So therefore, what is the condition? That we have condition A belonging to H and now B inverse belonging to H, and H is a subgroup. H is a subgroup, so it satisfies the closure property, and closure property says that if A belonging to H, B inverse belonging to H, their composition will also belongs to H. Therefore, we have AB inverse belongs to H. So therefore we have proved one condition where we have supposed that H is subgroup of G, and we have proved that for any AB belonging to H, AB composition B inverse binary operation is there here, that it may be multiplication, usual multiplication, it may be usual addition, or it may be some other function defined, binary operation defined. So this AB inverse belongs to H. Now next we move towards the next condition. The condition is sufficient. For that, firstly let me write condition is sufficient. Condition is sufficient. So now we will suppose that this thing, in the previous we have proved this thing while we suppose that H is a subgroup. Now we will suppose this thing and we will prove that H is subgroup. So let AB belonging to H implies AB inverse belonging to H is the given condition. Fine, that we now have assumed. And now what is the required to prove condition? We have to prove that H is subgroup of G. For this to prove subgroup, we have to prove all its property that it satisfies. Number one property is properties of group. Closure property we have to satisfy. Associativity, it will satisfy. Number three, existence of identity, we will show. Number four, existence of inverse. So we have to show that all these properties are satisfied uh, by H with respect to the given binary operation. Here it is existence of inverse. So for one by one we will prove all the property it is satisfying. Firstly, we will be proving that it is satisfying the existence of identity. Existence identity. Identity means the element which when operated with binary operation with any other element of that set, it gives the same element, same output. So for an example, we are given that A B belonging to H implies A B inverse belonging to H. So if we choose A and A same elements, this implies that A inverse will belong to H, and we know that when any element is multiplied with by its inverse, that gives the identity elements, implies H has identity element. So this is the property of a group, that subgroup, because it is a subset, so it will be a subgroup, that it has identity element. So we have proved that H has identity element. Next we prove existence of inverse. So this is the next point. This is the point number one. Now second, we will be proving existence of inverse. So this is the second point we are proving. We are given that let A B belonging to H. Again writing the given condition implies A B inverse belonging to H. Now from this we have that identity is in H. Now we have proved it. So in first place, if I take here, if I take first element A and that B belonging to H, these two elements, this implies that E B inverse belongs to H, and we know that any element multiplied with identity will give the same element as output. So this implies that for we have proved that any, because we have taken B was any element of H, so we have proved that for any B belonging to H implies B inverse belonging to H. So this implies that every element of H has inverse in it. So we have proved that inverse of each and every element exists. Secondly, we will prove the closure property. So this will be the closure property. We will be proving this one. So what does closure property says that next is closure property. So this is third point that we are going to prove. Closure means if we take any two elements A B belonging to H, this implies that their product A B should also belongs to H. So let we take A and B inverse, any two elements. So because now we have proved that inverse of every element will exist. So if we take B inverse will also be there. So we can take these two elements, and the given condition says that if the two elements are given, then this implies that A B inverse will belong to H, and we know that if we take inverse two times, so that will make it as AB, because inverse if taken 2 times is equal to the element itself. So this implies that closure property holds good. So we have proved that closure property holds good in H. Now next and the last is, you will see, next one is associativity. So now you will look, fourth one is associativity. Since we know that H is subset of G, if G is a larger group, then H is a smaller set. So every element of G is satisfying associativity. Means associativity means ABC is equal to ABC. So as we know that elements in H are also elements in G, so we can write that since associativity property holds good in G and H is subset of G, this implies that associativity also holds good in H. Therefore we have shown that H is satisfying all the 4 properties that a group has to satisfy, and beside that H is subset of G. Therefore we can say that, we can infer from here that H is subgroup of G. So in this video we have proved an important result. The result is that, once again I am reading out the result. Necessary and sufficient condition for a non-empty subset H, we have taken non-empty subset H of group G, is that for any A, B belonging to H, A, B inverse belonging to H, where B inverse is the inverse of B in G. So proved the theorem, this one. So now we will discuss what is the importance of this theorem. This theorem will act as an important tool to prove any subset H of group G to be subgroup. Whenever we will ask that prove that H is a subgroup of G, we will only take 2 elements A and B, will prove that A, B inverse belong to H, and then that condition only will prove that it is a subgroup. So this condition will act as a tool to prove H is a subgroup of G. So this is all I have from this lecture, and I hope that you will be able to understand this lecture. If you have liked the lecture, please like, subscribe, share and comment. Your comment in the comment section are always welcomed, valued, appreciated. So this is Dr. Rajesh saying goodbye, take care, bye bye.